Hello everyone and welcome to this presentation on statistical sampling. So before we can look at our sampling techniques, we're just going to look at a few words, few definitions so that we're happy when we use these words in future slides. So a population is defined as a set of similar items. So for example, a population could be the heights of all the students in the college. And then a sample is a group that is selected from that population. So we might choose the heights of the 6 youngest students in the college. That would be a sample of 6 from that population. So a parameter is a numerical value related to the population. So it might be we look at the mean height of the population, and we would denote that parameter using the Greek letter symbol mu. If you haven't seen it before, this is the Greek letter symbol mu. And a statistic is very similar, but it's a numerical value related to the sample. So if we were to take the mean height of the sample, then we would have gathered a statistic. And the symbol that we use for the statistic is what we call x bar. So this would be the mean of the sample, whereas mu is the mean of the population. One is a parameter and one is a statistic. So if we have a statistic, so for example, if we do take the mean height of 6 students from the population, we can then make an inference about the population. In other words, from that value that we've gained from the sample, we can estimate a value for the population based on that statistic, and that would be called an inference. Okay, so let's start talking about sampling in general then. So before we look at sampling, let's ponder this question. Is it possible to measure the heights of all the adults in an entire city? Now that would of course be a population. The heights of all the adults in an entire city would be the population of the city. Is it possible to measure everyone's heights? Well, the answer is yes. It is possible to measure the heights, but it's not very easy to do. And there are various reasons that make this idea impractical. So the first of those is time. It takes a lot of time to measure the height of everyone within a city. People move in and out of that city constantly, so they change jobs, they move houses, they just want to live in a different part of the country. Therefore, the population is forever changing, which makes the idea of measuring everyone very difficult to do. Some people may refuse or they're unable to be measured. And then finally, it's a matter of cost. It does take a lot of money to hire people to do the measuring of all those people. So there are various reasons why the answer to that question is yes, but it is not easy to do. So instead, we would normally take a sample from that population, and then we would make an inference about the population based on that sample value, the statistic. So there are different ways we could sample that population. We could group the people by their age and then randomly select some of the groups. We could use social media to ask for the heights of all your family and friends that live in the city. We could stand in the city centre on an afternoon and measure the heights of every 20th person that passes by. We could split the population into age categories and then choose a sample from each category in proportion to the size of the category. We could stand in the city centre and just measure the heights of 40 random men and 40 random women. Or we could number every adult that lives in the city and then use random numbers to collect a sample from that population. So all 6 of these methods are used. They all have their own advantages and disadvantages. They all have their own different names. And we will study each of them in turn and look at really what are the differences between them and how they differ in terms of what are the advantages and disadvantages of using any of these 6 methods. So the first one we're going to look at is simple random sampling. Now this is probably the most common method that we see at both GCSE level and at A level. And this is where we number every adult that lives in the city, and then we use a random number generator to collect a sample from all of those people that have been numbered. So this method has advantages and disadvantages. First of all, the advantages: every member of the population has an equal chance of being selected. But a disadvantage would be it could be difficult to collect the data from some members of a large population. Also, may be difficult or unable to number every member of the population. So our second sampling method is called systematic sampling. And of these 6 options that I gave you earlier on, it is this one which is our systematic sampling method. We would stand in the city centre on an afternoon and measure the heights of every 20th person that passes by. Again, the way that we would do it, number every member of the population, and then starting from a random point, choose every nth member to collect a sample of a given size. And again, there are advantages and disadvantages of doing this. If the sample is collected using the full population, it will represent a good spread of data. But disadvantages, again, may be difficult or unable to number every member of the population. Pattern in the data could also make the sample biased. So our third method of sampling is stratified sampling. Again, it is a method that we do see at higher level GCSE. Which of these 6 options is our stratified sampling method? It is this one. So we split the population into different age categories and then choose a sample from each category in proportion to the size of the category. In other words, if you had more 30 to 40-year-olds within a population, then you'd make sure that you choose more 30 to 40-year-olds than any other group when you're doing your sample. So the way that we do it is we divide into categories, and the amount chosen from each category is in proportion to the category size. And there's a little formula that we can use in order to decide how many from each category we are going to choose. And then we can take the number of people that we need from each of those different categories, which will then add up and result in the required number for our sample size overall. Again, as with all of the others, there are advantages and disadvantages of this method. So the advantages are that the use of prior knowledge to organise the sample means that you should get a representative sample. Disadvantages: it does take a lot of time to set up the sample. So our next method is quota sampling. So out of the 6, which one of these strategies is our quota sampling method? Well, it's this one, where we stand in the city centre and measure the heights of a predetermined number of men and women. So we've got 2 categories, and we decide for ourselves how many from each of those categories we are going to sample. So again, advantages and disadvantages. First of all, the advantages: we don't need the access to the full population, and it's easy to collect the data. Disadvantages: could be biased as the person collecting the sample decides the members, so it's not a random sample. Our next one, opportunity sampling. is this method. So using social media to ask for the heights of all your family and friends that live in the city. So the person collecting the sample picks the members by any method that is convenient for them. So it's very quick and easy to collect that data, but it's very likely to be biased as the person collecting the sample decides on the members. So it's not at all a random sample. And then finally, number 6, we have our cluster sampling method, which is this one. So we group people by their age and then randomly select some of those groups. And then within cluster sampling, there are 2 methods. One is called one-stage cluster sampling, which is once we've decided on those chosen categories, we use all of the people within the category. Or we have 2-stage cluster sampling, which is once we have chosen which categories we are choosing, we then take a random sample from those chosen categories. Advantages: can make a very large population more manageable. Other sampling methods can be used within a 2-stage cluster sample. So if we have too many individuals within the chosen categories and we want to take a sample from that chosen category, we can use other sampling methods to take that random sample. Disadvantages: does not include all members of the population, so might not be representative of the full population. Okay, so it's all good and well learning about those 6 methods of sampling, but we need to look at an actual example to see it in action so that we can compare how the different types of sampling are used within a particular context. So in this example, a head teacher wants to find the average age of 100 students that attend her school. And when they first join the school, they are put into an ability group, A, B, C, or D. And the head teacher asks 6 of the teachers to collect a sample of 10 students from the 100 within the whole school and to calculate the mean of those 10 students that they sample. And each of those teachers is going to use one of our 6 different sampling methods. So one teacher is going to use a simple random sampling, teacher 2, systematic, teacher 3, stratified, teacher 4, quota sampling, teacher 5, opportunity sampling, and finally teacher 6, cluster sampling. And the question is, what does each of these teachers need in order to complete their sampling method? So remember, they're going to collect 10 students from the 100 that there are in total using each of these sampling methods which we've already described. So what would each of these teachers need in order for them to produce their sample of 10 students? Okay, so for teacher 1 and teacher 2, remember teacher 1 is doing a simple random sample and teacher 2 is doing a systematic sample. What they will need is access to the whole of the population data. So here are the 100 ages of the 100 students who are at the school. We're not interested in what ability group they are in, just the ages of all 100 students. And to collect our simple random sample, we're going to need to use the random number generator on our calculator, which usually looks like this, as you can see on the right hand side. Now, teachers 3, teacher 4, and teacher 6, who are using the sampling methods that you see here, are going to need access to the ability group data that we were talking about earlier on. So here are those 4 groups. There are 14 members in group A, 21 in B, 36 in C, and 29 in D. Now, teacher 3, who's doing a stratified sample, is going to use all 4 of those groups, and they are going to choose a proportion from each of those groups depending on how big those groups are. So that's teacher 3. Teacher 4 has been asked by the head teacher to get 5 students from group B and 5 students from group C. So when they're doing their quota sampling, they're going to use those two groups in order to get their sample. And teacher 6, who's doing the cluster sampling, is going to collect 10 samples from exactly one random group, which will be decided upon later on. And then teacher 5, who's doing the opportunity sample, is just going to take 10 students from the group that they have currently sat in front of them, which consists of a group of 17 to 18-year-olds. So they're going to take a sample of 10 students just from the class that they've got in front of them right now. So there we go. We've now discussed what each teacher would need in order for them to collect their sample of 10 students. And then when each sample of 10 has been taken, the teacher is going to find the mean age of those 10 students that they have a sample of. So let's start with teacher 1. So remember, teacher 1 is doing the simple random sample. They have access to all 100 ages of all 100 students, and they're going to use the random number generator on their calculator to select the 10 people from these 100. So you would number them from 1 to 100, and then you would use your random number generator to get 10 numbers between 1 and 100, and it would be those 10 students who are selected for the sample. And here are the 10 students who were selected. So this is very random. And when we take those 10 ages and find the mean of those 10 ages, it gives us a sample mean of 13.7 years. So that's teacher 1. Teacher 2 is going to use a systematic sampling technique. Again, they need the ages of all 100 students, and what they have decided to do is choose every 10th person starting from the third. So you can see that it's a very systematic way of finding those 10 ages, and when you find the mean of those 10 ages, you get an average age of 14. Teacher 3 is going to use a stratified sampling method, so you can see that group C has more members in it than any other group, so we're going to be using more in our sample from group C than any other group. So in order to work out how many we would take from group A, we take the total number of students in group A, which is 14, divide it by the total number of students, which is 100, and then multiply by 10, because 10 is the total sample size that we want to take. And that works out roughly equal to 1. That's a rounded value because we need an integer in terms of the number of students that we're going to take from that group, which ends up being 1. For group B, there are 21 students altogether in group B. Divided by 100 again, the total number of students, and multiplied by 10 gives us roughly 2 students from group B. Group C is going to be our biggest cohort, so 36 divided by 100 times 10 gives us a value of 4, so we're going to take 4 students from group C. And finally, in the same way, we end up with 3 being taken from group D. And we can see that if we add those numbers together, 1, 2, 4, and 3, we do indeed get 10 students altogether for our sample size. So here is the 1 person from group A, the 2 from group B, the 4 from group C, and the 3 from group D. And if we find the average age of those 10 students, it comes out at 13.8. So that's our stratified sample. Teacher 4 is our quota sampling method. So they've been asked to get 5 students from group B and 5 from group C. So here are the 5 that I'm choosing from group B. Here are the 5 that I'm choosing from group C. And when I work out the average age of those 10 students, I get 13.3. Okay, so teacher 5, who's just taken the opportunity of sampling 10 students from the group that is currently in front of him, which consists of a group of 17 to 18-year-olds, ends up with a mean age of 17.4. And then finally teacher 6, who is doing some cluster sampling and is taking a sample from group D. So that's his cluster. And then within that group, they are randomly choosing 10 students. So again, they would be using the random number generator on their calculator to take 10 from these 29. And it turns out that these are the 10 students who that teacher takes, and they have a mean age of 13.6. So here are the results that we found. These are the average heights of each of the samples that we've taken. And then that would lead us to be able to estimate the average age of the population, the average age of the 100 students that are at the school. And so we would do that by working out the average of the 6 values that we found. And that works out at 13.39. So that's our inference, that's our estimated mean of the whole school based on the samples that we've taken. So how can we make these sample means more reliable? We can increase the size of the sample, so that would make the statistics more reliable, which would then allow us to have more confidence in the estimate of the average age of the school.